Hi, so what we're going to do today, we're going to find the variance of a random sample. So we have a table with our discrete values, 4, 5, 6, and 7, and 8. And then we also have the probability of getting those values, 0.2, 0.1, 0.3, 0.2, and 0.2 respectively. Okay? Now, I'm going to do things a little differently because I'm more familiar with other methods than what Hawks uses. However, if you do want to use them ways that Hawks goes with it, by all means go for it. That's no problem at all. So what I did, I wrote the formulas down of what I'm going to need to use. So standard deviation, like I said, a little different than what Hawks uses. So what I use is a standard deviation of x is equal to the square root of the sum of your discrete value minus your average squared times the probability of your discrete value occurring. And then when you take the square root of that, that's your standard deviation. But in the directions, it states to find the variance. Now, if you remember correctly, finding the variance means you're going to square your standard deviation. So, in other words, let's just kind of get our thoughts together. You are going to have to find the standard deviation, but once you find it, you go back and square it. All right? So, what I did here, I rewrote my values in a vertical table instead of a horizontal table. Just to me, I see it better when it's vertical. So our value is 4, the probability is 0.2. Our value is 5, our probability is 0.1. Our value is 6, our probability is 0.3. Our value is 7, our probability is 0.2. And our value is 8, also has the same probability of 0.2. Okay. Now, to find the other piece, we got to use the third column in the table that I wrote. So x minus mu of x squared. Now, mu of x is just the average of your x's. So if we go to the very first column of the vertical table, and we add 4, 5, 6, 7, and 8, well, we get 30. And 30 divided by 5, well, that gets us a mean, or a mu of x, of 6. All right? Now, we can take the average, we can take our discrete value and our probability, and then we can go ahead and plug stuff in. All right. Now, I have to do exactly what the third column tells me to do. So it is going to be 4 minus 6 squared. Well, 4 minus 6, well, that gets us a negative 2. And then a negative 2 squared, well, that gets us a 4. Okay. Now, let's see here. 5 minus 6 squared, that gets us a negative 1 squared. Negative 1 squared, well, that gets us a positive 1. And then we keep following that same pattern. 6 minus 6 squared, well, that gets us 0. 7 minus 6 squared, well, that gets us a positive 1 squared, which gets us positive 1. Hang on real quick. Let me just rewrite this as 0. There we go. So 0, positive 1, and then 8 minus 6 squared. Well, that gets us a positive 2 squared, which gets us 4. Okay? Now, I'm going to add in one little piece into that third column. In our standard deviation, we have to multiply the x minus mu of x squared by the chances of it happening. Okay, that's part of the standard deviation formula. So now I'm going to take what I got for my x minus mu of x squared, and I'll multiply that by p of x. So when I do that, this would be, on the first part, 4 times 0.2, which that gets us 0.8. And then we keep following the same pattern. 1 times 0.1, well, that gets us 0.1. 0 times 0.3, well, that gets us 0. 0.2 times 1, well, that gets us 0.2. And then 4 times 0.2, well, that gets us 0.8. All right. Now, going by our standard deviation formula, The symbol right here, that little E, means that we add up everything that we just did right in here. Okay? We add them up. In other words, we're going to add everything that we have in this little column that I just circled. Okay? So now, in this particular case, we have 0.8 plus 0.1 plus 0 plus 0.2 plus 0.8. That means we have 1.9. All right? Now, the standard deviation says, like the standard deviation formula, what that means is that now the 1.9 is everything we have inside our standard deviation formula. Okay? So now I can go ahead and substitute everything that I just circled in red. That means our standard deviation of x equals the square root of 1.9. So that means our standard deviation would be approximately 1.378 or 1.38. All right? Now, if you remember what your standard deviation, I'm sorry, not your standard deviation. If you remember what your variance is, it's your standard deviation squared. So if we go ahead and we square both sides, well, we go ahead and get back that 1.9. So this right here, what that says is that your variance is equal to 1.9. So in other words, you're still doing your standard deviation. But if you want to think about it like this, your variance is actually going to be that number you get right before you square your square root. Okay? So in this particular problem, your variance would be 1.9. And really, when you're trying to find the variance of discrete random variables or the standard deviations of discrete random variables, this process works the same every single time. I will recommend that it's a very good idea to draw out a chart. Drawing out a chart is a whole lot easier whenever it comes to organizing all your numbers. Okay? So as always, let me know if you guys have any questions of any kind. I'm happy to help. As I mentioned in the very beginning of this video, there are multiple ways to do it. I just prefer using a different formula that is located in my lecture notes. However, you still get the same answer as if you did it the way that Hawks presented as well. Okay? Like I said, let me know if y'all get stuck or have any questions. I'm happy to help. Until next time, guys, see you later.